Now, if I have map, we can simply implement the map using the unsorted list. Do you remember what is unsorted? Okay, we learn from the priority queue. Okay, there can be two kind of lists. We can sort the list, or we can use the unsorted list. In the case of the unsorted list, yeah, we can store the items of the map in a list as, let's say, if I want to use the doubly linked list. Do you still remember what is doubly linked list? We have the connection with the previous and next. So we can simply implement the list space like this one. The element will be the key and value. The element will be key and value. The element will be key and value, key and value. And then for this node, it has a connection with the next node. And this node has the connection with the previous node. In the map, actually, they have the structure. Okay. They have the class, and they also make the subclass. So the map base, we can have another kind of map. We call it unsorted table map. We can have hash map base. We can have sorted table map. We can have tree map. And in the hash map base, we can have chain hash map, and we can have rope hash map. So there are many variants of the map. Because of the time limitation, we cannot learn all those variants, so we will just look at some important variants. So in the map base abstract class, because the map base is the top one, so as you know, if we use the object-oriented programming and we learn about the inheritance. Okay, so if we learn about the inheritance, it means the subclass will inherit the properties of the superclass. So every of this subclass will inherit the properties in the superclass, which is the map piece. So in the map piece, we can define the nested item. So the nested item, yeah, we can define with the implementation, whether it is the hash tree, whether it is the unsorted list, or whether it is the sorted table, and etc. But we know that in the map, there should be key and value. So those are the data that we are going to use. And then when we construct an item, there will be key and value. And then we can define the common properties. The common properties means we have the equal. So we want to check whether the key is the same with the other key or not. Not equal. We want to check whether the parent object is not the same with the other object. Or if the key is less than the other key, and etc. So if we have the subclass or the subclass of the map base, then we will inherit the superclass. So the unsorted table map, this one, the unsorted table map will inherit the properties of the map base. Then whenever we create the subclass, it will inherit all the properties in the map base, and we can just define what are the important of the table map. So this is the unsorted list implementation. With the list space map, it means when we make the map with the list, so the performance, when we insert any item, it will take O1. Since we can insert a new item at the beginning or at the end of the unsorted list. So you know, if we have a list, okay, we can have a new item whether in the beginning or in the last part of the list. So it will take O1. Searching or removing an item, it takes ON. So if we want to find some element here, then the worst case it will be ON. Since in the worst case the item is not found, we traverse the entire list to look for an item with a given key. So the unsorted list implementation is effective for a small size or maps in which insertion are the most common operations. So if we have list space like this one, if we have many insertion, okay, if we insert the data, then it is good because it takes O1. But if we have many deletion or if we have many searching, then search and removers are rarely performed, then it is good. But if you search a lot, if you remove a lot, then you may consider another kind of data structure. So the next part that I want to explain is the hash tables. So this hash table is one of the subclass of the map, and there are many applications of this hash table, especially in these days. Let's look at the definition of this hash table. So let's recall the notion of a map. So map intuitively is an abstraction of the data using keys as the index with a syntax such as MK. So in the quiz, you know the MK is to get the value. Okay. We want to get the value with a particular key. So let's look at the very simple map here. Consider a restricted setting in which a map with n items use keys that are known to be integers in the range of 0 until n minus 1. For some n, it is bigger than small n. So let's say I have this list. Okay. And then in this list, I want to store the value. Let's say I want to store the value in the k equals to 1. And I can just put in the index 1, and this is the value. If I have the k or the key equals to 3, so I put in this key, and this is the value. So that's also the same when we use the kind of map. But there is another kind of more general about keys. What if our keys are not integers? So in the previous examples, we know that the keys is 1 or 9 or 13. So numbers. But if the keys are not integers, so how can we put it into this kind of environment? So we have a concept about hash function. So hash function is a function to map the general keys to the corresponding index in the table. For instance, the last 4 digits of the social security number. Yeah, maybe in some countries they will use the last 4 digits of the social security to indicate that this will be the integer location, or this will be the key for the prisoner. So we will use a kind of function to check what is the general key. So hash functions and hash tables. We call a hash function. It maps the keys of a given type of value to integer in a fixed interval. So we have a kind of data, and then we want to convert it into integer from 0 until n-1. Because we know if we have a kind of list, or if we have a kind of dictionary, we can have some data. Let's say this is n. Okay. So the number of the index will be from 0 until n-1. For example, we have the its x, or the x will be a kind of data. Let's say the data is this one, 0, 0, 0, 1, and I want to have a fixed interval. So the fixed interval is from 0 until n-1. Then any value which is x will be in the place of both n, and we have it is as the its x. Because this is the hash function for integer e. So for example, I have only 10 locations. I have only 10 locations, and then my data is 1010. So how can I put in this array? And one function before we place this number into this array or this list, we can use the hash function. So we can determine the key, which is the sx, and the way to determine is to make this number mod n, so we can get the remainder value. The integer xx, the result from this function is an integer, and this will be called as the hash value. Hash table for a given key consists of the hash function, which is this one, and then there is an array of size n. So we call this is table. So if you have array with the 10 location, then we call this is the array or the table that we want to put according to the hash function needs. And when we implement a map with the hash table, the goal is to store item k, o at the index I, where the I equals to its key. What is its key? Its key is the function of hash function. So the I will be the result of x mod n. So in this case, k will be the value here, then k mod n. We have the k mod n will be the index to place the data. So the SSN, this is the social security number. We can design a hash table for a map storing the entries. For example, in the entries, we have the SSN or the social security number, and then we know the name. So it is common. I think in your in the Korean case, we have the 등록번호, 주민번호, okay, and then the 주민번호 will be followed by the name. So the SSN, let's say that it is a 9-digit like this one. So it is a 9-digit positive integer, and in our database we have only limited size of the array. We want to provide only the n equals to 10,000. So we have only limited from 0 until 9999. Why? If the n is 10,000, it means the index will be 10,000 minus 1. So the last index will be 9,999. So our hash table use the array of n equals to 10,000, and we have the hash function, and the hash function will be the last 4 digits of x. So we can have like this one. If the social security number is this one, we will use the last 4 digits of x. What is the last 4 digits? 0, 0, 0, 1. Then it means this number will be 1, and we will put this one into the index number 1. We have another social security number. The last 4 digit is 0, 0, 0, 2. Because this number is 2, we will put it into the index number 2. We have 0, 0, 0, 4. So the last 4 digit is 4. We put this index 4. If the last 4 digit is 9998, then we will put this one into the last 4 digit. And this is the index to save this number. There's another kind of example. I have this 10. I have 10 locations, or I have 10 places. Now I have 11 items. So I have 11 items here. The first item is 1. The key is 1. The second item is 25. And the third item is 3. And then the next item is 14. And the next item is 6. And the next item is 39. And so on. But I have only 10. Sorry, I have 11. I have only 11 because it is started from 0 until 10. So it means the size is 11. Now I want to put 1. So if I want to put 1, because the key is from 0 until 10, then I can just put 1 in the index 1. What about 25? 25 is more than 10. So in order to put into this array, we can have a hash function. The hash function, the problem that we already had before, we can have the hash function, which is the x mod the n. In this case, n is 11. And what is the x? X is 25. So x mod 11. So this is the very simple hash function. 25 mod 11. What is the result? It is 3. Then we will put 25, C into this index number 3. Next we have 3. So in the index 3, of course, it is in between 0 until 10. So we can put directly into the index 3. And so on. So we can put into like this bucket. We call it, this is a bucket of array. So there will be questions. Why we put like this one? Because in this case, we have one index and there are 3 items. So let's see more about this one. In the hash functions, it is usually specified as 2 composition of 2 functions. So in the first, it means we have the key and we want to make it as integer. Because sometimes the key is not integer. For example, in maybe your student ID is integer, but in some cases, like say in your passport, in the passport, maybe you have a kind of text B9999201, something like this. Then, in order to fit with the hash function, you need to have the hash code. You need to change the key, which is this one, into integer. Maybe when you have the B9999201, you will omit the B and then you will just use the number. And then after we have the H1, we can compress. The compression means from the integer value, let's say we have 9999201, we can compress it to the array which is between 0 until n-1. So in many applications, we will apply the hash code first. Hash code is applied first, and then the compression function is applied next on the result. It means we will have this kind of function. This function is, the first we will apply the h1 function, and then after we apply the h1 function, we will apply the h2 function, and the result will be the function hx. So the goal of the hash function is to disperse the keys in apparently random way. So this hash function, if you learn more later, this kind of hash function is the basic idea when you create the blockchain. But this is just a very basic one. We use the integer value and then we assign it into a kind of array. In the hash codes, so like I was saying that the hash code is to transform from the keys, from any keys into integer. So the hash codes, let's say if the hash codes is from the memory address. Do you know what is memory address? Whenever you create an object in your computer, the object will be saved into the memory address in your computer. So the memory address will have some kind of values, and the values will contain text. So we can reinterpret the memory address of the key object as an integer. It is good in general, except for numeric and string keys. And then the integer cache. So the integer cache, it means if you have a kind of memory, let's say we have F 256 or 8 like this one. So this is the memory address. You can transform it to the integer cache. Do you know what is integer cache? Whenever you do with the computer will understand the binary code. The binary code, it will be like 0, 1, 0, 0, 1, something like this one. Okay. So if you are using this integer cache, then this will be very long. So we reinterpret the bits of the key as integer. If we want to use this one in order to integer cache, yeah, we need to reinterpret this bit of the keys as integer. But this one is suitable for keys of length less than or equal to the number of bits of the integer. So if it is too long, of course it is not possible. If the bit of the keys is still reasonable, then it is. So that's why some people, they think that if we are dealing with the hash code in the computer, so there's another kind of concept about the hash code. We call it the component sum. So we can partition the bits of the key into components of fixed length. So let's say in this case, you know, in your laptop, it is 64-bit. Okay. You know what does it mean? So the integer value, it has 64 items. Okay. So if your computer is getting better and better, then the length of the integer will be longer. So if you have 128-bit, of course it is faster. Okay. But yeah, when you use the hash code, if the longer the integer bits, then it will not make the computation more complex. That's why we can just make the component sum. If we have the 64-bit, we can split. Okay. And we can split into 16 or 32. Okay. After we calculate this into 32 and 32, okay. And then we can split again 16 and 16, and we can split again 8 and 8. Okay. And after we calculate the smaller integer, we can sum the components. So it's like the binary tree. But this kind of component sum is suitable for the numeric keys of fixed length greater than or equal to the number of bits of the integer types. So if we are dealing with the current computer, it is okay. But if we are dealing with the supercomputer or with the quantum computing, it is not okay. So there also another consideration when we are dealing with the hash code. With the bits, okay, we can consider the polynomial accumulation. The polynomial accumulation, it means, yeah, we can partition the bits of the keys into a sequence of components of fixed length, 8, 16, 32 bits, and we can evaluate the polynomial. It means, you know that this kind of bit, it is a kind of problem of power of 2. So 2 power of 2, and then 2 power of 3, and then 2 power of 4, 2 power of 5, and so on. 2 power of 3 is 8. 2 power of 4 is 16. 2 power of 5 is 32. So it can be more and more. So we can consider this one as the polynomial. Okay. The higher of the bits, then we can consider as the polynomial. So we can evaluate with the polynomial like this one. We have A0, we start with A1z, and then we go to A2z power of 2, we go to A3z power of 3, and so on until an minus 1, z minus 1. This is actually suitable for the string. So we usually choose the Z equals to 33, give the most 6 collision on the set of 50,000 English words. So this kind of codes, usually you can use it for dictionary. So in the dictionary, you will need to find out how you can place the English words. Let's say if you have 50 English words, 50,000 English words. You want to make 50,000 size of list. If you make 50,000 size of list, of course, it will be very huge. So we can reduce it with this kind of polynomial accumulation. So this means that we can make Z equal to 33. So we can reduce until about the 33 size. And then for every of this address, it can have like 6 collisions. So we will learn what is the meaning by collisions. So it mentioned that in this polynomial Z, it can be evaluated On. So based on this rule, we have the Horner rules. So if we use the polynomial things for the hash codes, we can have the On, and we can have this following polynomial are successfully computed. It's from the previous one is O1. So that's the way how we can do with the hash codes and how we can determine the size that is good for the placement. And there are another kind of function, we call it the division and MAD, multiply, add, divide. The division is the same like what we already saw before. We just do the mode. So the mode means we can just get the value, the remaining value, and the remaining value will be used for the placement. The size of n of the table is usually chosen to be prime. So this n usually a prime number. Why we should use the prime number? There is a reason, but I will not discuss the reason because it is a kind of derivation from a kind of mathematics. And for the comparison functions, we can use this multiply, add, and divide. The multiply, add, and divide, we can use this kind of formula: a multiplied by y and then plus b, and then we will do the mode with n. So this is assumed that a and b are non-negative, so that the a mod n will not be equal to 0. Thus, if a and b there are some 0, then a mod 0, what happens? Everything divided by 0 is infinite. So it is not possible. Or if it is a mod b, sorry, a is 0. Everything 0 divided with any number, then it will be 0. So we need to limit that one with the non-negative integers, and we can apply this formula. So otherwise, every integer will map to the same value. So we will look more details how we can apply this one. Okay, I will stop this one. I think I will continue this one on the next class on Wednesday. Okay, thank you very much for attending the class today, and see you on Wednesday.